integral over c 5z plus 7 by z square plus 2z minus 3, where c is modulus of z minus 2 is equal to 2. Okay, integral over c and c is modulus z minus 2 is equal to 2. So f of z is this much is f of z. Then what do you do to find poles? How to find poles? We equate the denominator to 0. So once you equate the denominator to 0, you can find the poles. Z square plus 2z minus 3 is equal to 0. So factorizing, you get z minus 1 into z plus 3 is equal to 0. Z is equal to 1, Z equal to minus 3. They are simple poles, okay? Now we'll check whether it lies inside the curve or outside the curve. The curve is mod z minus 2 is equal to 2. And here what we do? Substitute 1 instead of take z as 1. When z is 1, modulus 1 minus 2, mod minus 1 is 1. We take only the absolute value, and this is less than the radius. Here radius of the circle is 2. So therefore z equal to 1 lies inside C. Now take the next point, z is equal to minus 3. Z is equal to minus 3, mod z minus 2 is mod minus 3 minus 2, modulus of minus 5 is 5, which is greater than the radius. Here radius is 2, right? Radius of the circle is 2, and here 5 is greater than 2, therefore it lies outside the circle. Therefore z equal to 1 is inside, the other one is outside. We find residue for only for the inside point. Okay, outside point will become 0. So only for the inside point, since it is a simple pole, is familiar to you. You can find the residue using this formula. And here denominator just f of z, right? Denominator you split z minus 1 into z plus 3. Z minus 1 will be eliminated. Then limit z tends to 1, you get the value as 3. Then by Cauchy residue theorem, integral f of z dz is 2 pi I sum of residue. Only one residue is here, 3. So answer is 6 pi I. Okay, next question. Evaluate integral over c sin square z by z minus pi by 6 the whole square dz, where c is mod z equal to 1. So we take the function as f of z, sin square z by z minus pi by 6 whole square. Now how? Finding the poles, equate the denominator to 0. So z is equal to pi by 6. We get z is pi by 6. And from this, it's a double pole, okay? It is repeated 2 times. It is repeated twice because we have square here. It is a pole of order 2. Now we'll verify whether it lies inside or outside. What about the curve here? Given curve is mod z is equal to 2. Okay? Since it is of order 2, it is repeated twice, right? So m is equal to 2 here. Now given mod z is equal to 1, z is pi by 6. So we write, instead of z I take pi by 6. Pi is 22 by 7, that is 3.14 by 6.52, which is less than radius, which is less than 1. So it lies inside the circle. So we have the formula to find the residue of order m. When it is of order m, 1 by m minus 1 factorial, limit z tends to a, d m minus 1 by dz m minus 1, z minus a whole power m into f of z. Okay, so we will use this equation now. That is, here we have, okay, we have the equation. This is z minus a whole raised to m, z minus a whole raised to m into f of z. A is equal to, we have it here, a is pi by 6, m is equal to, order is 2, right? Order is 2, so we take m as 2. So now let us substitute it here. 2 minus 1 factorial, z tends to a is pi by 6. Okay, we have it in the next step. A is pi by 6. Then d power, limit is d m minus 1. 2 minus 1 is 1. dz 2 minus 1 is 1. So d by dz, power is 1. Then here z minus a whole, m is 2 whole square. F of z is our question, that is sin square z by z minus pi by 6 the whole square. Then next step what we do, 2 minus 1 is 1, limit z tends to pi by 6, a is pi by 6, d by dz of z minus a is pi by 6. Z minus pi by 6 the whole square into sine square z by z minus pi by 6 the whole square. Okay, so here, so now this denominator z minus pi by 6 the whole square will be cancelled. So you get sine square z. Now differentiating sine square d by dz, we have to differentiate it one time. Derivative of sine square z, we use x raised to n x raised to n minus 1. So 2z again sine z, derivative it is cos z, okay. So 2 sine z, for sine z it is cos z. Now limit z tends to pi by 6. So now let us change z as pi by 6. 2 sine pi by 6 cos pi by 6. So we get here 2 sine pi by 6 cos pi by 6. Actually this is into, okay, into. So here what we do is 2 sine pi by 6 into cos pi by 6, right? Instead of z we take pi by 6, and now what we do is pi by 6 instead of this pi by 6. So actually you cannot eliminate like this, okay? You should not eliminate. 2 is there, pi by 6 will be there. So what is pi by 6? So let me write that here. What is pi by 6? Sine 30 into cos 30 degree, pi by 6. 2 into sine 30 is 1 by 2, cos 30 is root 3 by 2. So cancelling we get root 3 by 2 as the answer left. So this is the residue value. So now what we are going to do is, now by using Cauchy residue theorem, we know integral value is 2 pi I sum of residue. We have only one residue value, that is root 3 by 2. Okay, root 3 by 2, 2 and 2 will be eliminated. Root 3 pi I. This is root 3, okay, not 2, root 3. Because we have root 3 here. Root 3 pi I is the answer. Next question, evaluate integral over C. E power 2z, z minus 1 the whole square, into z minus 2 dz, where c is mod z minus 2 is equal to 2. Take this as f of z, equating denominator to 0, z is 1 comma 1, z is 2. And now we know 1 comma 1, this is twice, right? This is repeated 2 times, double pole to single pole. So you can continue with the solution, you can try this on your own. You have to find whether it lies inside. I'll give the hint. You can substitute for z and you can find whether it lies inside or outside. And in the first case, when z is 1, it lies inside because the radius is, our question radius is 2. Okay, here you have radius is 2 and you get 1, so it lies inside. In the other case, you get 0. 0 is also less than the radius, so again it lies inside. So both the points lies inside. First point is a single pole, second point is a double pole. So find the residue. You can do that. For a is equal to 1, m equal to 2. A equal to 1 is double pole, okay? First one is double pole, 1 is double pole with m is equal to 2. Double pole means m is 2. So you can find the residue. You can do this on your own, similar to the previous question. Then you can eliminate the term e power 2z. Z is 1. So you get, first you have to differentiate. Okay, here you have 2 minus 1. 2 minus 1 d by dz. So you can differentiate it using u by v form. So what about u by v form? Derivative, this is u and this is v. Derivative of u by v square, v u dash minus u a dash. This is v, right? So v into u dash, then u into v dash by v square. V into derivative of e power 2z, 2 into e power 2z. E power 2z, derivative of this is 1. So you get this step. Then finally substitute z is equal to 1. When you substitute z as 1, you get 1 minus 2, 2 e power 2 minus e power 2 by 1 minus 2 the whole square. So our answer is minus 3 e power 2. Now the second root value of z is 2, which is a simple pole. You can find the residue for that because it lies inside. You can do this on your own. You get the answer as e raised to 4. Now by Cauchy residue theorem, integral over c f of z dz is 2 pi I sum of residues. 2 pi I into sum of residue, you have to add both the residues, minus 3 e power 2 plus e raised to 4. So minus, we cannot add this further. So 2 pi I into e power 4 minus 3 e power 2. 3 e power 2 is the answer here. So this gives the integral value.